let's solve an absolute value equation, and we'll solve a couple of absolute value inequalities. All right, so our first one is an absolute value equation. It's a pretty simple one. The absolute value 5 minus x equals 7. To solve an absolute value equation, you write two equations. The first one looks exactly like the original, except that we've removed the absolute value signs. The second one, we remove the absolute value signs. Don't change any of the signs within the absolute value. You just remove the absolute value signs, and then this is equal to, and we make the constant a negative, negative 7. Now I solve my equations, so I subtract 5 and I get negative x equals 2, which means x equals negative 2. And when I subtract 5 from this side, then I get negative x equals negative 12, and that means that x equals 12. So I get two answers. If I want to graph these answers on the number line, then here's negative 2, here's 12, and I'll just put closed in circles on those two numbers. If I want to write the answer a little more correctly, then I would use set notation. Negative 2 and 12. All right, let's solve a couple of absolute value inequalities. Now this is going to be pretty similar to what we did with the equation. Okay, so here's my first one. 2x plus 3 is less than or equal to 9. So here's an absolute value inequality. I'm going to write two inequality statements. The first one looks just exactly like the original, but we've taken the absolute value signs off. But in the second one, I'm going to make two changes. First, I write my 2x plus 3 without the absolute value signs. And then I take my inequality sign and I flip it, and I make the number negative. So we have two things that we change. And then there's a third thing that we do. If I have an absolute value that is less than, a less than means this is an and situation. I need to put the word and between my two inequality statements. All right, so let's solve these two inequalities. We have 2x is less than or equal to 6. Divide by 2, and I get x is less than or equal to 3. Here, I have 2x is greater than or equal to negative 12. Divide by 2, and I have x is greater than or equal to negative 6. Remember, I have the word and here. So this is my answer. Now let's graph that to see what that looks like. So here's my negative 6, here's my 3. All of the numbers that work for this part of my inequality, all of the numbers that are solutions here are in this part of my number line. And all of the numbers that work for this part of my inequality are on this part of my number line. Well, the numbers that work for both, the numbers that satisfy this inequality and this inequality, they satisfy both inequalities, are right here in the middle. So when I graph this, I'm going to be shading all of the numbers here to indicate that they are solutions. Now, it's also an equal to, so it may be that you use the filled-in dots to show that it's also an equal to. It may be that you use the brackets. Whichever, it doesn't matter. But this is the way you would graph your solution set. You could also write an and compound inequality so that it's all in one statement. You cannot do this with an or. We're going to do an or next. But you can only do this with an and. And when you write a compound inequality, an and statement, remember that your inequality signs need to both be facing in the same direction. It's also nice if you put the numbers in the same order that they appear on the number line. All right, so let's do another one, but this time it's going to be an or. So we'll start down here. 6 plus 3, absolute value of x plus 4, is greater than 12. Now, notice this one has a couple of issues. I have got some things sitting over here with my absolute value that need to move because we can't write our two inequality statements until the absolute value is by itself. So the first thing I'm going to do is move the 6. And so then I have 3 times the absolute value of x plus 4 is greater than 6. Divide both sides by 3. And I have the absolute value of x plus 4 is greater than 2. Now I can write my two inequality statements. So x plus 4 is greater than 2. Now, this is a greater than. So an absolute value greater than is an or. And then my second statement is x plus 4. I flip the inequality sign and I make the number negative. And there's my second inequality statement. All right, when I solve for x, then I get x is greater than negative 2 or x is less than negative 6. Well, let's see what that looks like. On the number line, here's negative 6, there's negative 2. So all of the numbers that work for this part of my inequality, x is less than negative 6, are over here. And all of the numbers that work for this part, are x greater than negative 2, are over here. But this is an or. So my answer has to satisfy this or this. It doesn't have to be in both places. All right? So we can shade this end of my number line to satisfy 1, this end of my number line for the rest of the solution set. And since there is no equal sign, it may be that you use an open circle to indicate that. It may be that you use a parentheses. Whichever one you use is fine. But this is how you can write your answer and graph your solution.